Good morning, everybody, and welcome to lesson 2.10 of the Explorers Life Mobile Marine and Off-Grid Electrical Academy. Nate and Steph here. We're doing a live stream this morning so that we can hopefully get some input from all of you about what issues you're having on a power audit over the last 9 weeks. We've been putting out lessons that teach you how to determine how much power various items use. And this live stream is sort of the thing that ties it all together, because once you have the information you need from those last 9 lessons that we've done, you kind of need to be able to compile it into a particular format so that you know how big of an inverter that you need, how big of a battery bank you need, and then how much solar you should probably have in order to power all those loads that you have. So we're going to be using the information that we've had from the last 9 lessons of this academy, putting that into our brand new calculator, which maybe Steph can put into the chat below. While she's doing that, we'll just kind of get... as a few people are filing in. We're going to get to it here pretty quick, probably within the next 2 to 3 minutes, because I scheduled this out in advance and I don't want to waste anybody's time. So thanks for tuning in this morning. And if you have any questions throughout this process, specifically about power audits, put them in the chat. Steph is going to be putting all that stuff into a list, and then we're going to use that in the last half of this. So the first half is going to be sort of the items that we've pre-compiled together, and then the second half of this live stream, the second 30 minutes, is going to be from your suggestions. So Steph put the power audit calculator down in the chat box. So Steph, anything before we get started?
No, I don't think so. Let's
Okay.
get into it.
Let's just get right into it. Okay, so I'm going to share my screen here. And we've already compiled everything from the first 9 lessons of the academy. And if you don't know how to figure out, what kind of power outputs various devices get, check the video description of this live stream, because I'll put the playlist to this academy, or to this particular section of this academy, into that, because there is some prerequisite information. But we're playing off of the information from everything that we've learned so far. So here is the new power audit calculator. Let me go back to the first screen. I was playing around with it earlier. So let's just run through these instructions and then get right into it. So what we're going to find here is, in the calculator, we're going to have a device name, a spot where you can put the device name, the daily watt hours if you know it. If you don't know it, then you're going to leave it blank, and it's going to be automatically calculated from watts and run time. And you'll see that as the example as we move forward. The max operating watts of the device. And this is important because this is going to tell you what the size of inverter that you need to power all your devices. Runtime in hours. And this is important if you don't know the daily watt hours used, because you can calculate the daily watt hours used, or you can estimate the daily watt hours used from the max operating watts and the runtime. And the calculator does that for you. Now, if the device cycles on and off during operation, we've got a duty cycle slider, and that's going to be for something like a air conditioner that turns on and off, or maybe even a refrigerator. If the device is an AC powered device inverter used, and it's desired that the devices can be used at the same time as other devices. So for example, if you've got your computer plugged in and you're also brewing a pot of coffee, you can toggle the simultaneous AC load option to yes, so that your inverter is big enough to power those devices all at the same time. And lastly, for accurate inverter sizing, at least one AC load must be selected to run simultaneously, because if you don't do that, then it's going to say you don't have an inverter, which isn't going to work. So let's just get right into it, and we'll put all of that to use. So the first device, Steph, I'm going to have you pull up the document that we had going on, and we'll just kind of talk back and forth and have you tell me what devices are on that. So the first device is going to be
Our coffee maker.
coffee maker.
Excuse me.
And the watt hours. We don't know the watt hours on this, so we're going to jump down into watts and runtime. So how many watts does that coffee maker use?
That is 1550 watts, 1,550.
And you can determine the watts used by a coffee maker by the label on the coffee maker itself or on the product spec sheet. And then for runtime, you just really just have to use a stopwatch and see how long that coffee maker runs for.
Yep.
So when we tested our coffee maker, how long did that runtime?
That was about 6 minutes.
6 minutes. And our calculator is listed in a factor of hours. So that's 0.1 hours right here. And if you struggle with those calculations, up here under helpful calculations and conversions, we actually have that just a bunch of various conversions in here that you might need to use for the calculator. These are just helpers. You don't have to use these if you can just do the quick math in your head. So this does not have a duty cycle. If you turn your coffee maker on, realistically, it just turns on and brews the coffee and then turns off. So we can leave this at 100%. And the simultaneous AC load, we are going to come back to that once we get the entire power audit built out so we can determine which AC loads we want to be able to run at the same time. Okay, device number 2, what we got?
We have an iPhone 15 Pro.
And do we know our watt hours used?
We do. We have 11.52 watt hours to recharge that phone one time.
And that was, say that one more time.
11.52.
11.52 watt hours. Now this is a battery powered device, so you have 11.52 watt hours in the battery, and that's just, we're going to assume that we're going to use that phone from 100% to 0% one time per day and then recharge it overnight. So this 11.52 watt hours to recharge the phone's battery is coming from our off-grid battery bank. And so we can just put that in there. Now for watts required, since it charges via USB, USBs, they don't take very much power from the inverter. So the inverter doesn't have to be particularly big to accommodate for this. But for really small loads like that, I almost like to, think of them like a single light bulb. So, there's lots of information on what USB can charge from or what the charge rate is. But for watts, we're just going to put in 100 watts there so that it can be accounted from if you were to be running this from the inverter. Okay, runtime. We're going to leave this blank because we already know the watt hours. We've already put that in right there. So we don't need to know the runtime. Duty cycle stays at 100%. Simultaneous AC load, skipping it, coming back to it later. Device number 3.
Device number 3 is a laptop computer. So similar to the phone, we're going to be charging that to 100% and then unplugging it, using it down to 0%, recharging it again.
Okay, perfect. And so for that, do we have our watt hours already known?
We do. It's 93.48 watt hours, but we are going to be charging it 2 times per day.
Okay, so we need to double that.
Yep, and I forgot to write that down, so let me calculate that.
186.
186.96, so round up to 187.
187. 187 watt hours. Okay, we also need to know the watts of the computer while it's actively running or charging. And whenever we were running this test, I observed that to be 120 watts. And that was observed just with a pretty inexpensive AC power meter. And remember that the watts that we're putting in here is to size the inverter later on in this calculator. So watt hours used is capacity from battery, and then watts is instantaneous load that's going to be used for inverter. Runtime, we don't need to put that because we already know the watt hours from our AC power meter. From our battery capacity that we are charging and then discharging twice per day. Duty cycle stays 100%. The computer doesn't cycle on and off. A simultaneous AC load. We're coming back for it later. Device number 4.
Device number 4 is an Xbox.
Xbox for some Red Dead Redemption. Not sponsored. Okay. Do we know our watts or our watt hours? What information do we have?
Pardon?
What information do we have on that for? Sorry.
We actually measured that with an AC meter. So an Xbox is listed at 315 watts on the power supply, but from our research, we found that it doesn't use that all the time. That's more of just like powering up, not necessarily during gameplay. So we plugged in our AC meter, and during 2 hours of gameplay, we had 629 watt hours.
629 watt hours, and so I'm going to put that in. That was for 2 hours of gameplay. So if you're using your AC meter and you play longer, this is a game of close enough, basically. If you play for 2.5 hours every night, if you play for 5 hours every night, you just kind of have to make sure that you factor those averages into your power audit, depending on how important these loads are to you. So I've got 629 watt hours. That's measured from our AC power meter there in the watt hours box there. And I also went ahead and put 315 watts into this box right here because that's the maximum amount of power that the Xbox could ever draw from the wall outlet. So this is going to be for inverter power later on. Runtime, we don't need to know that because we measured our watt hours with an AC meter, and so we just put that right in there. There's no duty cycle on this. Duty cycle would be kind of an interesting thing on an Xbox because, with the duty cycle, that's assuming it goes on and off completely. But, with an Xbox or something like that, the wattages used during gameplay depends on if you're on a pause screen or if you're an active gameplay rendering or a loading screen and stuff like that. So it kind of has a duty cycle, but man, that'd be impossible to calculate. So we're just going to leave that to 100%. Okay, device number 5. What do we got?
Device number 5, we have, speaking of duty cycles, we have an air conditioner.
Air conditioner.
Excuse me.
And what do we know about our air conditioner from a power standpoint?
From a power standpoint, we are at 1,300 watts at a 50% duty cycle for 650 watt hours. Running for 6 hours is a total of 3,900 watt hours.
Hey, our calculator worked. Outstanding.
Great.
Perfect. So I've got 1,300 watts, so that's going to be running on high on the Nomadic that's the X3.
That's the X3 DC air conditioner.
The X3 DC air conditioner. We're going to say that we're going to run it for 6 hours. Oop, don't want to print. And then we're going to run it for 6 hours with a 50% duty cycle. So during that 6 hours of runtime, we're saying that the air conditioner is going to be on for 20 minutes and then off for 20 minutes and then on for 20 minutes and then off for 20 minutes. And that's what a duty cycle means. And 50% is just sort of like a rough guesstimate based on, that video that we put out about air conditioners and figuring out how much power that they actually use.
Yes. And actually, I just realized down on my notes, I have that the Nomadic air conditioner that we have is a 2-stage air conditioner. So on eco mode, on that air conditioner, we could drop it down to a total of 2,160 watt hours.
And then do we have the watts used on eco mode?
720.
720. Yeah, so realistically, for the sake of the power audit, which would we rather do? I think we just leave it in high at 1,300 That way, we for sure have enough power to cover either high or eco mode. Let's just kind of bank on worst case scenario. We can always go to the results and then see how much battery bank capacity it uses.
Sure.
And then we can go back into the devices and say, well, let's kind of play around with these numbers.
Yeah, and I think that's definitely a like per person like situation of, if you're camping mostly in, Arizona during the summer, you probably want to calculate that on high all the time. And probably for more than 6 hours. But yeah, for our usage, I doubt we would be really using that unless we're at an event that's in a hot area, which is where we use our air conditioner the majority of the time.
Would you put a note down in our sheets of things to talk about later about air conditioner? And because we actually tested our air conditioner the other day when we were down in Arizona, and the results were pretty good. But yeah, we'll talk more about that after the power audit. Perfect.
Okay.
Back to it. What's our next device?
Our next device is lights. So we have LED lights, 10 puck lights at 2.5 watts each.
2.5 watts each, so that's 25 watts for the entirety of all the lights.
Yep.
Oops.
I also have this calculated at 156.25 watt hours. We're running it for 375 minutes per day, which is...
What's that in hours?
I think it's 6.25. Yeah, 6.25.
So a couple hours in the daytime or in the morning and a couple hours before bed.
Exactly.
More or less. Perfect. No duty cycle on this. We're skipping simultaneous AC load for now and come back to it. So 156 watt hours. Did that sound correct?
Yep, that's exactly right.
Outstanding. It's like this is based on math. Okay.
Which is good because it can check my math.
Yeah, true. Okay, device number 7.
Device number 7 is a 12-volt water pump.
Okay, 12-volt water pump. Do we know the watts of the water pump?
We do. It's 90 watts.
Okay.
And we're estimating that it runs for about 15 minutes a day. So we actually already calculated the 22.5 watt hours.
15 minutes a day. What's that in hours? That's 0.25. 22.5 watt hours.
Yes.
Outstanding.
Precisely.
No duty cycle on this simultaneous AC load. Come back to that later. Next device.
Next device is a max air fan.
Okay, and what is our information on that?
So we're going to put this in at watt hours because the max air fan has variable speeds. And so obviously each, speed 1 through 10 uses a different number of watts. So we're going to put that in as 704 watt hours. And that's based on, we're estimating that we run it on speed 10, which is the highest speed, for 16 hours, and speed 1 for 8 hours. So 43 watts at 16 hours and 8 hours at 2 watts.
Perfect. And that's a pre-calculated thing that we've already talked about. And we talked about that back in lesson 2.09 of the Academy. And so if you need more information about like how the max air fan gets its watt hours used, go back and check that out. It's a pretty short video, but I think it's pretty insightful. So watts, what is the peak watts that we see?
43 watts.
So on high, the max air fan uses 43 watts. And we don't need the runtime because we've already calculated the watt hours based on some high speeds and low speeds there. Duty cycle, we're going to leave that to 100% because it doesn't cycle on and off. And simultaneous AC load, we're going to come back to that realistically pretty much next. So that's all that we have in that we've done in this academy from lessons 2.01 through 2.09. And we're going to go ahead and move forward because I think this actually does a pretty good job of encapsulating like what people use on a day-to-day basis. So we can just scroll down here. There's room for up to 20 devices on this calculator, but if you don't have that many devices, then you can just leave these blank. If you have more than 20 devices, figure out your 20 most power-hungry devices and then just do those. If you have more than 20 like high-power usage devices, I think something's kind of gone wrong. So you're just going to have to pick the top 20. So click next down here. And it's going to give some information on what size of system that you need. So let's just run through this real quick with what we see. We see the calculated daily power used, which is the minimum battery bank size. So that's 480 amp hours at 12 volts, which is 5.77 kilowatt hours. So, this figure is 480 amp hours at 12 volts. If you're doing a 24 volt battery bank or a 48 volt battery bank, this stuff is going to change. Or this is going to change. The amp hours is going to change because that's just how amp hours works. But the kilowatt hour, this is not going to change regardless of what's battery or voltage of the system. So recommended minimum solar array wattage is 961 watts, and that is simply this times 2. AC inverting capacity needed is 1550. Now we need to circle back around to this because we have more than one AC load. This would work for this, but realistically, all this is doing, this number here is only pulling information from what is the singular item in the list and what is the biggest watts pulled. And so it's only recognizing one of those loads in the system. So we're going to have to come back to that in just a second. Minimum battery bank size to support the inverter. So here's an interesting thing we had to put in here. So each inverter has a minimum battery bank size that it needs to run, and the multi-plus 2K is 200 amp hours, and so that's there. But you need 480 amp hours to supply power for all of those devices that we've already talked about. But this is the minimum, so you have to have at least that. So system voltage recommended 12 volts. Because this is a fairly small system with only 1500 watts on the inverter and less than 1450 watts on solar. So let's go back and talk more about inverter capacity because it's currently a little bit off. So the simultaneous AC load is what we need to talk about now. And so we need to go back through our devices and ask ourselves, hey, what AC devices that are powered from a standard household outlet, what devices do we want to run at the same time? Because currently the results that we showed, they only account for, the devices that you have that checked. So it was only seeing the coffee maker basically, because I think if we turn that off and go back into that next page, yeah, it says AC inverting capacity needed 0 watts. And so,
That's not right.
You have to have at least one, which I have the one as default on there. But realistically, we need to go in there and check, next to simultaneous AC loads, what devices do we want to be able to run at the same time? Okay, so the iPhone, we can go ahead and say that that's going to be an AC load, if you're plugging it into, I know that you can plug an iPhone 15 into a DC outlet, but maybe you have an off-grid house that you don't have any,
12 volt outlets.
Yeah, any 12 volt outlets. You're not using 12 volt loads. And so we're going to go ahead and say that that's a simultaneous AC load. If you got a camper van, you're never going to plug it into a standard household outlet. You could toggle this off. So got all kinds of flexibility there. Laptop computer. I'm going to say that I am going to want to use my laptop at the same time that I'm using my coffee maker, because that's pretty important. Xbox. I'm going to say that, I'm pretty much gaming in the evenings, and I don't need to use my Xbox at the same time as the coffee maker. So we're just going to leave that off, I think. So we're going to bypass that. But if, you did want that, you just simply toggle that on. Air conditioner. That's a DC load for our particular air conditioner. So we're going to leave that off, because it doesn't come through the inverter. LED puck lights, those are 12 volt puck lights. We're going to leave those off because that's a 12 volt load and it does not come through the inverter. 12 volt water pump, again, 12 volt load not coming through the inverter, so it's not a simultaneous AC load. So we leave that off. Max air fan, exact same story. We're leaving that off for the same reasons. So we can scroll on down here and hit next. Okay, so now it's saying that we have an AC inverting capacity needed of 1770 watts, which is recommending a multi-plus 3 kVA. And I understand that this isn't above 2000 watts. Well, you'd see 2K versus 3K. Well, kVA versus watts is a little bit different in the way that it's calculated. So on the back end of the calculator, I've got a little bit of a safety margin built into it so that you're for sure able to run whatever it is that you're trying to run, with no problems. And so for 1700 watts continual power usage, you should really be in the range of the multi-plus 3 kVA over the multi-plus 2 kVA. So that changes things from, in the minimum battery bank size to support the inverter up to 400 amp hours at 12 volts. It doesn't change anything up here though. So realistically, this system size is going to be great here on, is going to be really consistent with this. Okay, so there's some more information here that you can kind of read through, but I think I've explained all of this pretty well for the most part of what we're seeing here in the more info. But then, once you have this information, what do you do with this information? Well, you want to, this information is good to have, but, if you can't do anything with it, the whole reason you're doing a power audit is probably because you're trying to build an electrical system, I would imagine, unless you just like doing power audits in your spare time, which more power to you if that's the case, I suppose. It's a weird hobby, but, everybody's got weird hobbies, I guess.
I mean, that's kind of what you do.
Oh, that's true.
Called out.
So we can go back into the calculator and then scroll down a little bit, and then our system picker is right there. And so, Steph, let's walk through this system picker and kind of show how you can tie the calculator to the system picker. So what kind of project are we working on?
A camper van.
A camper van. Do we have any 120, 240 volt split phase loads?
No, we do not.
We do not. So those are going to be huge loads. Typically, that's, no.
Yeah, that's for residential.
That'd be like dryers.
Dryers, yeah.
For stoves.
Brain went blank.
Welders.
Yeah.
Big air conditioners.
Yeah.
Because you can have some split phase mini splits. Air conditioners, but yeah, there are some that are 120, but then there's some that are 240. Okay, yeah. So do we need 50 amp shore power?
Not in this fan, no.
Yeah, and most of the time, if you're trying to make that determination, typically if you have more than one air conditioner, that's when you need 50 amp shore power, but just with a single air conditioner or less, 30 amp is fine and is the most common. So how many amp hours of battery bank capacity do you need? So that's where, the power audit that we just did comes into play. So we can come up here to the calculated daily power used and look here at 5.77 kilowatt hours. And then we're right here. So 5.77 kilowatt hours falls in line with right there. How much inverting power do we need? So we're going to come up here to this, and we need 1770. The recommended AC inverter size is the multi-plus 3K. So we go back down to the calculator here, and we just select the 3K. And this is recommending our Explore bundle, which features a multi-plus 3K, a minimum of 400 amp hours of battery bank capacity. Click into Explore this kit, and that will take us to our store, to that. Internet's being a little slow because we're streaming at the same time. And it has everything that you need to build that kit, from the base kit to monitoring to adding solar. And for solar, there's all kinds of options. In that power audit, it recommended a particular range. I think it was 800 something watts of power. And, there's all kinds of options depending on, how much roof space availability. But we're not going to get too much further into that. So, basically the whole goal of the power audit is to get you to, this screen so that you can figure out, what system that you need. So that is pretty much how that power audit works. And I hope that was helpful. And so we're going to kind of stop with this particular power audit. We're 30 minutes in at this point, and I'm trying to keep this whole stream under 1 hour so that you guys can get back to your weekend. And but I do want to make sure to cover items that y'all have questions on. So if y'all have questions about like what kinds of devices how much power various devices use, leave them in the chat box below the live stream, and we'll use some of your examples. Steph, has there been any questions or devices or anything like that come across so far?
Yes. So first question we've got is, would changing a 24 volt alternator to a 48 volt alternator and also a 48 volt inverter change this calculation?
So the question is about voltages, and the answer is no. The voltages of the loads don't change based on your inverter capacity or your alternator capacity. The voltage of the system should be based on how much inverter capacity you have, and just switching to 48 volts doesn't affect the power audit a single bit. And also, on our the power audit calculator that we made, a long time ago, 4 years ago or whatever that was, it mattered if you had 120 versus 230 volt loads for all of you who are not in the United States or North America. In this calculator, it doesn't matter, because everything's being converted into watt hours. So if you have 230 volt loads, you're from Europe or wherever, everything gets converted into watt hours, and then the outputs are, they are what they are. And there's no issues using this calculator if you are not on 120 volt grids. So the answer is no to that question.
Ray had a follow-up. I was thinking on the solar side of the equation.
No, also no. So the solar is calculated from. Let's see, everything got deleted whenever I went into my next screen. So the solar side of things is calculated from the battery bank side of things. So if you have your 8.13 kilowatt hours, that's 600, and this number here for minimum solar array wattage is simply this times 2. And this is just this times this. So it's just an equation that it doesn't matter. No. So the solar doesn't change. Your solar needs to be the size that it is to refill these kilowatt hours from your battery bank. So, no.
Sorry, did you have your screen shared while you were saying that?
I'm sorry. So, yeah, screen sharing. My bad. So basically, this minimum solar array wattage here, this 1356, is simply the amp hours at 12 volts times 2 gives you this. So, and this part really doesn't matter from a voltage standpoint, because it's just a calculation. this kilowatt hours is simply this number times this number, amps times volts equals watts. And so this is all just a calculation. And really, this is the only thing that matters, the kilowatt hours. And, we could figure out what the kilowatt hours to watt hour or watts of minimum solar array wattage is. I mean, there's a formula for that. But, realistically, just switching to a different voltage system, that doesn't affect any of this at all. No.
Awesome. For a battery bank size, would you also want to include the inverter standby draw in the power audit?
You could, yeah. So inverters take a certain amount of power to simply be on. But, what I recommend on a power audit is to get your calculated number and then round, round up to the next nearest battery size or round up by a factor of 1.5. Depending on how many days of, maybe you find yourself in a stretch of bad weather and, you're not getting any solar and you're having to, stretch your battery bank capacity to 2, 3, 4 days. So the calculator is just a calculator for a single day. And then you can always double your battery bank capacity depending on how much backup battery bank capacity that you want to have.
Yeah, I think that's an important distinction to make, is that this is for one day. So if you're recharging every single day, if you're plugging into shore power or you're driving enough or you've got enough solar to recharge that battery bank, this is kind of that perfect calculation. If everything goes exactly how you calculated it, which is probably not going to happen in real life. But you want to account for that too when you're, if you're up in the PNW and it's raining for a week straight and you're not getting a ton of solar. I know that's when we were on the road, we had a much larger battery bank than what we needed necessarily for one day, because we were working off grid and oftentimes we were in cloudy weather, and so not getting all of that solar.
Yep, very much so. So these calculations are just a starting point, and then you can kind of adjust from there. Okay. Any other questions or items that have shown up in power audits?
Nothing in questions right now. Let's see. From questions that we had previously, we did have a question specifically about the Max Air fan. And I think we've covered this pretty well in our power audit that we just did, as well as in 2.9, lesson 2.9 of the Academy. Mm-hmm. But this was just, kind of I'm confused by the Max Air fan because you can use it at variable speeds. So can you just kind of maybe go over one more time how the variable speeds affects the power audit?
Yeah, sure. So, variable speeds of something affecting a power audit, let's just put two of those things into the calculator. Screen share, back to page 2, previous year. So let's go down to device number 10. Pardon me. Device number 10, and we're going to put it on, we're just going to call it Max Air Fan Speed 1 or Speed 10. And we're going to put the watts in here. So, what are the watts at speed 10?
43 watts.
43 watts. And then we're going to say that we're going to run it on high for how long? Let's call it, 4 hours a day.
On high? Yeah. Oh, sorry. Yes. Sure.
4 hours a day on high. And that gives us 172 watt hours. Now on device 11, let's say that we're going to do Max Air Fan Speed 1.
Speed 1 is at 2 watts.
2 watts. Oh, that's the watt hours. Okay, I'm actually going to... So a little bug with the calculator that I was not able to fix. I get to tell on myself. If you put the watt hours in here, it automatically overrides anything that you put down here. So we're going to move down to device 12. Speed 1.
So you're not allowed to mess up on this calculator.
Yeah, don't mess up. Watts, 2 watts. Runtime is, let's say, the remaining 20 hours of the day?
Sure.
And then that takes 40 watt hours. So you can kind of see, like, pretty much immediately, comparing max air fan speed 10 to max air fan speed 1, 4 hours is going to take 172 watt hours, and then 20 hours is going to take 40 watt hours, just because it's the difference of, running a device at 2 watts versus 43 watts. That's 20 times as many watts. And so that's kind of the effect that running a max air fan on the 2 different speeds for various times, affects the power output of the power demand of the entire system. So does that sort of clear that up?
I think so. Yeah.
Perfect. Before we move on to the next question, I wanted to talk about something else that I just realized that I did with this calculator. This calculator, by the way, is brand new. So I'm still trying to remember how I made it, because I made it like 2 months ago, but we're just now releasing it. The team here at Explorers Life has been using it for the last couple months, but it's still new. And so I'm trying to remember how, sort of all the stuff that I did to make this work properly. But I just went back into the power audit just a second ago and went to our air conditioner, which was rated at 1300 watts. So let's pretend that this was actually an AC 120 volt air conditioner. And I want to be able to run that at the same time as the coffee maker and everything else in the system. So I toggled this to simultaneous. I toggled simultaneous AC load to yes. And then let's check out how that affects the power audit. It doesn't change anything on the battery bank size. This has changed from where we talked about it just a minute ago, because we added a couple loads. But the minimum, let's see, the AC inverting capacity, that air conditioner gets added to your AC inverting capacity needed, which is now, with a coffee maker, with an air conditioner, with a computer, is at 3,000 watts. And so realistically, to be able to sustain, that to 3,000 watts of power, you need to be using the a 5 kVA inverter charger, which the Victron Quattro 5 kVA inverter charger. And I also made this calculator so that it actually recommends a system voltage, and the system voltage is based on what the AC inverting capacity needs to be. And so since we're up above 3 kVA of power, and need a 5 kVA inverter, you should be doing a 24 volt system, because the size of inverter is simply too large to put on a 12 volt system. And all that's reflected in the battery bank capacity as well. So I kind of put that in there so that it helps all of you out in actually recommending a system voltage. And then you can still put all that stuff in the power audit, as previously talked about. And this number here, solar wattage was brought up earlier, and if this changes based on your system voltage, and you can kind of see that no, it doesn't, because at 348 amp hours at 24 volts, this is no longer 12 volt amp hours times 2, it's 48 volt amp hours times 4 at this point. So you can kind of see how that calculation ends up being. If you keep on going back on this thing, let's go to let's say that our air conditioner, let's say we have a second air conditioner. Let's come down here to device 13, air conditioner number 2. Watts, an additional 1,300. Let's actually say this is a bigger air conditioner, 2,000 watts. Runtime, 6 hours. Duty cycle, 50 minutes. Simultaneous AC load on. So we really need some substantial battery capacity at this point. This is an off-grid cabin or whatever the case is. AC inverting capacity needed. So this is recommending now a dual Victron Quattro 5 kVA system, which needs to be a 48 volt system. So you can kind of see how I've built this calculator to have our battery bank capacity as a factor of kilowatt hours, but also our recommended system voltage based on, what those actual loads are. And so, I think that's where, this calculator kind of does a better job of, giving you some more actionable outputs. So I don't know. I'm kind of geeking out about that because that's a question that a lot of people we get all the time. They're like, hey, can you build us a 48 volt system? And it's like, well, what are your loads? And they're like, a phone. It's like, you don't need a 48 volt system for just a phone. So, this calculator kind of helps you figure out what the actual recommended, battery bank voltage for your needs are based on your actual load outputs. Okay. I think I've rambled on enough about that.
Great. Okay. Another question. Chris asked, how much power does the Serbo GX take, or security cameras, or gas and diesel heaters? So I think the main question here is, how do I figure out how much power do all of these devices take? What device I specifically have?
Sure. So if that circles back around to this entire playlist of the Academy, which is in the video description below this stream. And lessons 2.1 through 2.9, they show you all the different device types that you need, or that you're asking about. And so let's go through those step by step and kind of rough figure those out in our last 13 minutes here of this stream. So we've got, what is it, Steph? What's the
Serbo
first one?
GX.
Serbo GX. So the Serbo GX is going to have its power output listed. I'm not going to look it up right now, but do you know off the top of your head?
I don't. It would be listed on the data sheet, though.
Yeah, so it's listed on the data sheet. If anybody in the chat knows off the top of their head or can really, really quickly Google it, we can go ahead and put that in there. But, that's going to be a device similar to any of this other stuff. So, we can say Serbo GX, blah, blah. We just figure out how many watts it uses whenever it's in use. Okay. Nobody here. So we're going to pretend that this is 20 watts. You can look that up on the data sheet of the Serbo, and it's running for 24 hours a day, which gives us 480 watt hours. And so you just put in whatever the actual watts of the Serbo GX is into there. Perfect. Okay. What's the next device?
A security camera.
Security camera, exact same thing. I mean, you could just
and I know
plug
we
that in
did a
here.
Ring camera at some point. I don't remember
We did.
when.
So I think the watts of the security camera was somewhere in the ballpark of, it was real small. It was let's call it 5 watts. 0.5 watts? No, it was 0.5 amps is what it was. Mm-hmm. And so you just do your amp to watt conversion. If you've got it memorized, you can just plop it in there right there, or you can go up to the helpful calculators conversions there.
You're not screen sharing.
Screen share. Sorry, guys. So you can go back into the screen share here, and you can figure out 0.5 amps. Oh, found a new bug.
Uh-oh.
Darn. For some reason, you can't plug that in. We can do it the old-fashioned way. Security camera, 0.5 amps times calculator, 0.5 amps times, I think that Ring camera, it was, I think it might have been 12 volts. So that's 6 watts. So you just put 6 watts in right there. And then it's going to be running for 24 hours. And then that's giving you 144 watt hours there. So all of, the Serbo GX and the security camera, realistically, it's the same thing. You just find out the watts of the device, how long you're running it, and then it gives you the watt hours here. And then it gets calculated on page 3 of the calculator. What was the third device?
It was actually a gas or diesel heater.
Yeah, so that's a pretty good one too. So let's say E-Spar heater. So that's a little more complex one because a heater cycles on and off. So the running watts of the device, we can look it up, but let's just call it 50 watts while the fan's actively running. And I just figure that's probably about the same as a max air fan for the most part. And then the duty cycle would actually need to be changed. We're going to say that we're going to run the heater for 24 hours a day, not 42 hours a day, 24 hours a day, which gives us 1200 watt hours. But let's say that heater's cycling on and off throughout the day, changing its duty cycle to 50%. That's 20 minutes of runtime and 20 minutes of off time, 20 minutes of runtime, 20 minutes of off time. And then that gives us 600 watt hours. So that's pretty much how the heater's going to work. Now, a thing about the heaters is, heaters take a fair amount of power to power up. They may take, let's call it 200 watts for 1 minute while the unit is powering up and everything like that. But realistically, if something happens for just 30 seconds or 1 minute, it's a little bit of an increased load for that short of time. It sort of doesn't matter in the overall, power audit scheme. By the time you get your power audit kind of dialed down and you round up for your days of autonomy of, how much power you're going to have for more than 1 days, that's not going to matter. And so I usually just recommend not worrying about those startup loads for the sake of power audits, because we built in a little bit of safety factor on the AC side if it was an AC load. So, but that's pretty much how you would do the E-Spar diesel heater there. So, and Ray actually just shared the servo was 2.8 watts for the servo without the screen. And so you just put that 2.8 watts for the servo without the screen in there. And then you have to figure, it's how often are you checking your servo with the screen on? It's maybe add up to a total of 5 to 10 minutes a day. It might not be significant. So, yeah. Okay, what's next?
That's all the questions that we've got.
That's all the questions. Fantastic. Okay, so I think let's go ahead and just call it quits right now. I want to keep this under 1 hour so that people watching this on replay, it's not 3 and 4 and 5 hours long, because a power audit isn't that complicated. By the time you go through, lesson 2 of this, their playlist 2 of this academy, and then do this power audit, you're going to have a really good idea of how much power you need in your system and be able to size your system appropriately. And, if you get through your power audit and you have numbers that are just too high, they're out of your budget, or, you can't fit that amount of equipment inside of your transit, whatever the case is, you may just have to dial it back a bit, but you can go forward and backward in this power audit a little bit and make those adjustments as necessary. The other day we had somebody who was like, I need to run my space heater and my air conditioner and my Tesla coil and all this other stuff at the same time. And I'm like, well, that's fine, but you're going to need 4 inverters wired in parallel to supply that amount of power. And he's like, well, I don't have that kind of budget. And it's like, well, we're going to have to dial back the expectations of what you can actually put into a vehicle from a budget standpoint, but also a space standpoint, because that stuff takes up space. So, anything else?
Nope, that's it.
Wonderful. Well, thank you everybody for tuning in. We hope to be doing some more live streams soon. If you have suggestions on live stream topics, let us know in the comments below or in the chat box. But thanks for tuning in. I hope this was helpful. We'll see you next time.